Hello and welcome guys. In this new video, we will discuss the first internal test of data science. Let's get started with part A. In part A says statistical characterization of feedback data. The first question says that give three more commonly used static measure of characterize dispersion in student feedback data. Variation in teaching quality scores lab, faculty rating or peer collaboration effectiveness. Discussing how this measure can be computed silently in large student database. Three common used statistical measure for characterization display in student feedback data are first is standard deviation and variance. Definition: standard deviation measures the average distance of data point from the mean. Variance is the square of standard deviation. You can see the formula of this. Advantage of this is most widely used as a disper measure. Consider all data points expressed in same units as original data deviation. In standard deviation, slide computation in large database. Use vectorization operation in library like numpy, pandas for batch processing. Implement increment calculation. You see the formula of this. Le- Leverage database aggregation function. Select stdd EV score from feedback. In second part of this, interquality range IQR. Definition: the difference between the third quality question number 3 and rest quality question number 1 represent the spread of the middle 50% of data. You can see the formula. Advantage of this is reboost to outer layers, easy to interpret, useful for identifying skewed distribution. Client computation in large database use percentile function, select percentile, count 0.75 minus percentage count 0.25. Recompute quartilization and store in summary table index data by scoring range for faster queries. Third, coefficient of variance CV. Definition: the ratio of standard deviation to mean expressed as a percentage allow comparison across database with the different units or scales. CV formula of this. Advantage of this: scale independent measure enable comparison across different feedback categories. Useful for comparing relative variance. Effect. Computation in large database. Compute one with select STDDV score upon average score into 100. Cache result for different feedbacks categories. And last one is parallelize computation across database partition by category or time period. Let's move on to the next question. Suppose that the student feedback rating on a scale 1 to 100 on faculties monitoring effectiveness even in sorted order. You see this. The, the, the question seconds A section is talk about what is the mean rating and what is the median. B is what is the mode of the data and comment on its modality, Bayern model and tri-model. C says what the mid-range of the data. Estimate, and the D section is estimate the rest of qualities. Question number 1 and the third qualities of question number 3. Give the positive number summary of the rating. Draw a box plot of the data. Enough. And G says how is the quantity plots different from a quality quantile plot this context. Given data for sorting, n is equal to 26 observation, and we can find the mean and median by this formula. So the answer of this is mean equals to 31.38 and median equals to 27.5, and mod and modality in B. The value appearing most frequently in datasets. You can see in this PDF the highest frequency of any number who's come from most time. So the number is 25.3, and the 35 4 time has the highest frequency in this mode. So the mode of this question is 35. Modality. The data is a unimodal because it has one clear 35 with frequency 4 node, while other values 25 with frequencies show local concentration. 35 is the distinct mode. And let's move on to the section C. Mid-range. Mid-range equals to minimum plus maximum upon 2. So the right answer is 41.5. The first qualification of question first and third qualification of question 3. Using the position method, positioning, you can see the formula of this in the PDF. So the right answer of question 1 is 20 and question 3 is 35.25. Move on to the E question. 5 number summary. So the 5 number summary consists of 1 minimum 13 question 1 first quartile 20, median second is 27.5, third quartile is 35.25, and maximum is 70. 5 number summary. Move on to the F question. Box plot of the data. You can see the box plot data in this PDF. Outliers is 70, and there all the functions are there. Move on to the interpretation. Box extend from question 120 to question 3 35, 25 representing the middle 50% of data. Median line marketed at 27.5 inside the box. Whiskers extend to approximately 52 on the right. Outliers 70 is an outlier beyond 5 1.5 into IQR from question 3. And IQR's formula given inside of there. Upper fence question 3 plus 1.5 and into IQR equals to 35.25 plus 1.5 into 15.25. So the right answer of this is 58.125, which is less than 70. It marks as an outlier. And last one is G. Quantile quantile plots versus quantile plots. Display the quantity of a single database against their value. X-axis quantile values 0, 0.25, 0.5, 0.75, 1, 0. And x-axis is the actual value at those quantile positions. Purpose visualize the distribution shape of one database. Quantile plot. Compare quality of two databases against each other. X-axis quantile of one database is the theoretical normal distribution. Y-axis quantiles of another database is the sample data. Purpose test if sample data follows a theoretical distribution or compare two distribution. Quantile plot would show how the feedback rating are distributed distributed across the percentile and visualize spread and skewness and outliers. A QQ plot would compare the feedback rating against a theoretical distribution, e.g., normal distribution, to access the normal assumption. Let's move on to the next question. Question number 3. Question: suppose student lab infrastructure satisfaction score are grouped into interval with the following distribution. So you can see the table in this. Compute an approximate median satisfaction score for the student. Solution: first identify the total number of student by adding all the values in n. Find the median position, and median position equals to n upon 2. So the median is 1.5. No, this is not 1.5. This is 1597. Build cumulation frequency table. So you can see the chart of this table. Identifying the mean class, the median position is 1597, looking at the cumulative equation. So therefore the median class is 21 to 50. Step 5, apply median formula for group data. So where this? So after applying this formula in this, so the answer is 33.94. So the approximate median satisfaction is score 33.595, or approximately 34, we can say, scale 1 minus 110. Interpretation: about half of the student rate lives infrastructure satisfaction below 34 and half rate it above 34, indicating moderate satisfaction level overall. Move on to the fourth question. In the Department of Lifelong Learning, a feedback survey collected both students' age and their self assessments of learning productivity given in the given for the 18 student in this chart. First, calculated the mean and median and standard deviation of age and percentage productivity. Draw the box plot for both. Draw a scatter plot and a QQ plot to study the relationship. So move on to the solution of this. First, measuring the age data of this in productive data. Find the mean by the formula of this median. So the mean of this is 47 and median of this is 51, and standard deviation will be uh, 13.90, and mean of this 29.41, and the median is 30.7, and standard deviation goes to 69.27 after percentile 8.33. B section, box plot for the age productivity qualities, numbering and calculate the first question position and third question position. After this, you can see the box plot of this. So, for the productivity percentile, the first question position equals to 26.35, and question 3 position equals to 34.225. After the calculation of this, 5 number summary equals to 7.8, comma 26.35, comma 30.7, and 34.225, comma 42.5. Scatter plot for QQ. The scatter plot would be shown the relation between age x-axis and productivity y-axis. You can see better it in this graph. Move on to the interpretation of scatter plot. This appeared to be a weak to moderate positive relationship between age and productivity. Student in a middle age range 47 and 57 show higher productivity percentage. Younger student 23 to 27 shows more variable and generally lower productivity. An older student 58 to 61 show high and consistent productivity. QQ plot. A QQ plot compares quality of age against qualities of productivity percentile to assess if they follow a similar distribution, productivity and quantity in this graph. Interpretation of QQ plot. The QQ plot shows the deviation from diagonal line, indicating different distribution shapes and age has more symmetric distribution, higher median closer to the mean. Productivity shows slight left skew, mean and is smaller than median. This scatter suggests different understanding distribution, so age and productivity percentile may be linear related to may follow different statistical patterns. Summary of table, key formulas and measurements are there. Measuring mean, median, mode, standard deviation, and IQR, mid-range, CV, and grouped median. End of this solution. Use case of this. Formulas are in the table. You can see very well. For use of this case is average value sensitive to outliers. Use of this median. Central tendency, robust outliers, most and the mode, most common rating, standard deviation says measuring of spread, and the IQR saying middle 50% spread of robusting. Simple range of measure because of mid range. CV is relative variability, and grouped median is median of grouped data.